Hey guys, in this video we're going to be covering activity 60.4. It's our last video for Target C, and our mastery learning objective is I can solve real-world problems by drawing a diagram and applying the properties of similar triangles. So, still setting up our proportions, still being able to use our side splitter theorem if we can. We're setting up proportions, cross-multiplying, and solving for our missing sides. The only difference is that now it's going to be a real-world scenario. So looking at our first example here, it says at a certain time of day, a 1.8 meter tall person standing next to the Washington Monument cast a 0.7 meter shadow. At the same time, the Washington Monument casts a 65.8 meter shadow. How tall is the Washington Monument? So basically you have someone standing next to an object. The sun is shining, and obviously both things are casting their own shadow. So we want to draw a diagram that models the situation, and that's what we're going to be doing in our first example. So we have some monument. I'm just going to have this be my monument. I'm not very crafty. And then I have a person that's standing looking at this monument, right? So the first thing it tells me is that my little guy here is 1.8 meters tall, so that's my person. It also tells me that he casts a shadow of 0.7. So basically we have the sun over here, right? This is my sun. Again, I'm not an artistic person. And the sun is shining down. And this is my ground. And obviously it's going to cast some shadow. So basically what's going on is that my little person here, his shadow is obviously after him, right? It's whatever this length to this length is. So this is going to be 0.7 meters. All right, it's also going to tell me then that the monument cast a 65.8. So 65 is going to be from all the way over here all the way to here. And this is going to be 65.8 meters. We want to figure out how tall the monument is. So what we do not know is this length. We want to figure out that height. Well, the good thing is that we have two triangles here. And we can set up a proportion that relates the shadow that's casted to the height of our little person here. So what we're going to be doing is setting up a proportion that basically has the height of the person or monument, the height of the person over the height, the height of the monument. So I'm just going to put the object because shorter to right. That's going to equal then, if we're doing the height of the person, then you have to have the shadow of the person. Shadow of my little guy. It's a little person. And then the shadow of my object. JCT. Alright, so looking at my picture here, my person height was 1.8, right? That was that 1.8 right there. So this is going to be 1.8 over the height of the object, which we didn't know, right? That's our x. That's going to equal then the shadow it casts. Our shadow of our person is 0.17 over the shadow of our object was 65.8. All right, we have a proportion, we have a variable. We should know how to solve now is just by cross multiplying. So cross multiplying this way and this way. 0.7 times x. I'm going to go ahead and kind of just extend this over here. 0.7 times x is just 0.7 x. 1.8 times 65.8 is going to give us 118.44. Still the same steps. These are getting multiplied together, so I'm going to go ahead and divide by 0.7 to get my x by itself. And that's going to give me x equaling roughly about 169.2 meters. That is the height of our monument. So determine the height of the Washington Monument. It's roughly about 169.2 meters. All right, we're going to do the same thing, drawing a picture, setting up a proportion, and then solving for whatever missing length or side that we are, or that we don't have, right? So next example says, a 6 feet tall tent standing next to a cardboard box casts a 9-foot shadow. If the cardboard box casts a shadow that's 6 feet long, how tall is it? So what we have here is a tent. This is going to be my little tent. Looks kind of like a triangle, right? And again, my son's over here, and it's casting down a shadow. And I have a box. This is my box. And some other information. What does it tell me? It tells me that my tent was 6 feet tall. So this height here is going to be 6 feet. It also tells me next to a cardboard box, cast a 9-foot shadow. So my shadow of my tent is 9 feet. So from here to here is 9 feet. Then it tells me if my cardboard box casts a 6-foot shadow, how tall is my box? So from my box, from here to here is 6 feet. I need to figure out how tall my box is. And actually, if I fix this line, I guess it's a little off, huh? My box should be a little tad bit taller. Maybe it should look something like this. Forgive me for my misdrawing there. Right, because I made my box kind of short there. All right, but setting up a proportion, again, didn't really matter, but I like to make sure that it makes sense to you. So setting up it the same way. So the height of our box is going to be proportional then to the height of our tent. And those are going to be proportional to the shadow of the box. Remember, if box is at the top, then box has to stay at the top in both fractions. This is shadow of the tent. So my height of the box, well, we don't know what that is, right? That was my x. Over the height of the tent, that's 6 feet. This is going to be equal to the shadow of the box. So my shadow of the box is 6 over the shadow of the tent, which is 9. I didn't need to write the feet there. We don't need the units in the problem as long as we have our units in our final answer. So there we go ahead and cross multiply. 9 times x is going to give me 9x. Cross multiply 6 times 6, that's 36. Opposite of multiplying by 9 is dividing by 9. And x, therefore, is going to equal 4. So the height of my box is actually 4 feet. All right, last example here. So the telephone booth is 8 feet tall, casts a shadow of 4 feet long. Find the height of a lawn ornament that casts a 2 feet shadow. So as you can see right now, we're going to have some triangle, right, with an object that's in the middle. So if we have a telephone booth, our telephone booth is 8 feet tall, right? Sun's over here. And it casts a shadow that's 4 feet long. So from here all the way to here is 4 feet. And then it says that we need to figure out what the height of this lawn ornament is. So we don't know what the height is, but we do know that it casts a shadow of 2 feet. So setting up our proportion just like we would in the last examples, we're going to have the height of our ornament over the height of our phone booth, and that's going to equal to the shadow of our ornament over the shadow of the telephone booth. So, our height, x, over the height of the phone booth, which is 8. That's going to correspond to, and be proportional, use orange, to the shadow of our ornament, which is 2, over the shadow of the phone booth, which is 4. I'm going to go ahead and cross multiply here. 4 times x. Wait, can I tab down a little bit? Ooh, too far. 4 times x is 4x. 8 times 2 is 16. Opposite of multiplying is dividing by 4 on both sides. And 16 divided by 4 is 4. Therefore, our ornament there is going to be 4 feet tall. Okay, that brings us to the end of Target C. There is a little mini quiz, so please make sure that you're ready to take that. Good luck.